Okay, so we're going to be talking about general functions now. So we've talked a lot about AH and K with absolute value functions, but what happens if we get a graph that looks something like this that we can't necessarily write an equation for? This would be kind of like something we would call a piecewise function, which we'll look at later on this week, if we did have to write an equation of it. But what we've been talking about with AH and K can be translated to a general function, but the rules pretty much stay the same as what we talked about with the absolute value function. So you'll notice that the A's, the H's, and the K's end up being in the same spots that they were in the absolute value function. So we're just going to look at this and we're going to make our connections. So a translation we'll look at first, and that basically shifts the graph of a function either horizontally or vertically, so either left or right or up or down. So from when we were talking about the AH and K with absolute values, we knew that the H value ended up inside of the absolute value symbols. So when we kind of generalize this to some sort of general function, you'll notice that it's going to be f of something, and that something with the H is going to end up inside of a set of parentheses. And that's going to be still representing our horizontal translation. A vertical translation we know kind of has to do with the K value, and we know that that's kind of at the tail end of our function, so not in the absolute value symbols from what we were talking about with those functions. If we want to generalize this to a general function, you'll see that this is going to be kind of notated as f of x either plus or minus k. Again, not on the inside of the parentheses where the h value would go. And again, plus or minus just means that depending on what the sign of the h or the k is, would decide whether or not you're going to be adding or subtracting that value. So we're going to be looking at just a couple of quick examples, and we'll be kind of making those connections with what we saw in the absolute value function. So say I just give you some general function f of x minus 2. So I'm noticing that the minus 2 is falling on the outside of the parentheses, so that must mean that that's my k value. And my a value, remember, always multiplies outside. So if we don't have anything here, remember that that's really multiplying by 1. And if there's nothing on the inside with the x, kind of think of that as like an absolute value symbol for a second. If there was nothing inside of there, we would say that the h value would be 0. So what's happening here, if we know the a value is 1, the h value is 0, and the k value is -2, the only thing that's happening, there's no stretch or shrink, there's no movement left or right, but there is movement down 2 units. So basically, if I wanted to take this to be my f of x function, again, it's not really going to be that easy to write an equation of this function because there's a whole bunch of pieces going on at once. I could potentially take these points and move them each down 2 units and make a table of values that way. But we're going to kind of apply what we know about transforming tables of values from the absolute value function. And what we're going to do is we're going to actually use these points here on this f of x graph as almost our parent table of values. So what I'm going to do is I'm going to make a list basically of these 5 points here in my parent table of values. And the way that we set up our table of values is always going to be in ascending order. So you should be putting the least x value first and the greatest x value last. So when I list those points, I'm going to go ahead and work my way from the left to the right. So my parent x value here is -5. Its corresponding y value is 2. Move on to this point, its x value is -2. Its corresponding y value is 2. This point here, x value of 0, y value of -3. This point here, x value of 1, x value of 3, y value of 1. And then this point here, x value of 5, y value of -2. So just for this particular function, this is our parent graph. So if the graph doesn't look like this isn't going to be your parent table of values. It's really going to depend on where your points are on the actual graph. But now that we know how to apply A's, H's, and K's to a parent table, that's basically what we're going to be doing down here to get our translated graph. So we know that H's transform the X's, but if there's the H value of 0, that really means that I'd be doing X plus 0 or X minus 0, which would really mean here that my X values from my parent table would be exactly the same. Over here, remember that we want to multiply by a and then add or subtract k. So here we would be doing 1 times y, which again is just the same thing that we started with, but then we also need to subtract 2 from that. So applying our a value and then applying our k value. So if I take each one of my y's and subtract 2, well, 2 minus 2 should give me a 0. Here, 2 minus 2 should give me a 0. Negative 3 minus 2 should give me a negative 5. 1 minus 2 should give me a negative 1. And then negative 2 minus 2 should give me a negative 4. So basically, we come up with new coordinates that we want to graph. So let's look at what this graph looks like compared to the parent. So negative 5, 0, negative 2, 0, 0, negative 5, 3, negative 1, and then 5, negative 4. So if we connect these dots from left to right in order, you'll notice that the graph kind of looks the same, except it's been shifted down, which we already knew from just looking at the equation. We knew that it was shifted down 2 units because of the k value of negative 2. So same idea of what we were working with the absolute value functions. The only difference is that our parent function ended up being different because our points were in different spots. And that can work for any function that you're given. You can always make a parent table of values and then use your transformations to shift the graph. So let's look at one more having to do with the horizontal translation. So now you see that, again, this is some general function f of x, but the value is within the parentheses. So again, think about that as being like your absolute value symbols almost. So what that means is that that's our h value. So that's telling us that our h value is 1. We don't have anything multiplied out front, so our a value is still going to be 1. And then we don't have anything added or subtracted here at the end, so our k value is going to be 0. So the only thing that's happening is that our graph is going to be shifted to the right 1 unit. And that's because of our h value of 1. So again, we could take all these points and we could literally just move them to the right 1 unit. But again, applying what we know about our table of values, I'm going to, again, just take these points of this graph to be my parent table of values, same way that we did in the last example. So we said that was negative 5, negative 2, 0, 3, and 5. Over here was 2, 2, negative 3, 1, and negative 2. And what I'm going to do is now I'm going to apply the fact that we have an h value. So all of my x's, I should be adding 1 to. Because again, h value is 1, we should be adding down here. So negative 5 plus 1 is going to be negative 4. Negative 2 plus 1, negative 1. 0 plus 1 is 1. 3 plus 1 gives me 4. 5 plus 1 should give me a 6. And then if we apply our transformations to our y's, well, what we're really doing is we're going to be multiplying by 1 and either adding or subtracting 0, which really means that all of these y values here are going to stay exactly the same. So 2, 2, negative 3, 1, and negative 2. And again, these are ordered pairs that we can now graph. So negative 4, 2, negative 1, 2, 1, negative 3, 4, 1, and then 6, negative 2. So when we connect these, again, going from the left to the right, we should notice that the graph again looks pretty similar, except now we've pretty much just moved all of the points to the right 1 unit, which again, we knew was going to happen up here just from looking at the function. All right, so let's look at a couple more transformations. So we talked a lot about reflections and how that happens. So the reflection happens when your a value is negative. So in our general function, what that's going to look like is now the negative is going to be out front. So in this first example, that's exactly what we want to do. We know that our a value is going to be a negative, and again, that's going to be a 1 if there's no number there. Our h value, we've got nothing going on inside the set of parentheses, so that must be 0. K value, we've got nothing going on at the end, so that's going to be 0. So the only transformation here is going to be a reflection over the x-axis. And again, that's because the a value here is negative. So again, my parent table of values is again just going to be the points, these 5 points that we're getting from the graph. So negative 5, negative 2, 0, 3, and 5. And then that's going to be 2, 2, negative 3, 1, and negative 2. And the only thing that's happening here, again, since we have no h value to apply to our x's, all of our x's are going to stay the same because really we're either adding or subtracting 0 here. So it's going to stay negative 5, negative 2, 0, 3, and 5. And if we apply our A and our K, we should be multiplying by -1 and then either adding or subtracting the K value of 0. So the only thing that's going to be changing now is going to be our Y values. So when I multiply each one of them by -1, -2, -2, +3, -1, +2. So let's go ahead and graph these and see what this looks like. So -5, -2, -2, -2, 0, +3, 3, -1, and 5, 2. And again, I'm going to work my way left to right, connect these points together. And you should notice that that basically looks like your graph flipped upside down, which is exactly what we said was going to happen up here. All right, let's look at another one, but including just one more transformation. So now we've got a couple things going on here. We've got an A value, so that's the negative out front, so -1. We still don't have an H value because there's nothing going on inside the parentheses, but we do have a K value of +2 because that's on the outside over here. So what's happening is we are reflecting, definitely, because we've got that negative A value. And then we have a vertical transformation. So we are shifting up 1 unit. I'm sorry, up 2 units. So again, parent table, still going to be those points. So I'm just copying -5, -2, 0, 3, and 5. And then 2, 2, -3, 1, and 2. Sorry, -2. And then again, since we have no H values, X values are still going to stay the same because we're adding or subtracting 0, which is going to keep them exactly the same. But we do have two different things going on for the Y's. So I'm going to multiply everything by -1, and then I'm going to take everything and add 2. So applying the A value of -1 and then adding the K value of 2. So that's going to be -2 plus 2 should give me 0. Again, just multiplying -1 times 2 is -2, plus 2 is going to give me 0 again. -1 times -3 is a +3, plus 2 will give me a 5. -1 times 1 gives me -1, plus 2 should give me a +1. And then -1 times -2 is a +2, plus 2 should give me 4. So I'm going to go ahead and graph these points. So -5, 0, -2, 0, 0, +5, 3, +1, and then 5, 4. And again, I'm going to connect going left to right. So again, definitely should look like your graph is flipped over, but again, we're also applying a different transformation. We're shifting it up 2 units. So it's not going to look exactly the same as what we did over here with our reflection. It's going to be pushed up 2 units. All right, and then comes the stretching or compressing. Just so you guys know, compressing is really the same thing as saying a vertical shrink. So if you see that word compression, that means exactly the same. So it's either going to be a vertical stretch or a vertical shrink, or in other words, we call that a compression sometimes. So same rules applies when we're talking about the absolute value function. Your A value is going to be found out in front of your general function being multiplied. And we know that there's going to be a vertical stretch when the absolute value of your A value is greater than 1. So it could be 2, it could be 3, it could be 10, it could be 100. And it's going to be a vertical compression or a vertical shrink when your absolute value of your A is between 0 and 1. For example, like 1/2, 1/3, 2/3, 3/4, those kind of fractions. As long as they're between 0 and 1, that would indicate that you're going to have some sort of vertical shrink or vertical compression. So looking at just kind of a basic function, if we have 2 times f of x, so here's my general function. I know that 2 is going to be my A value because it's out front, it's being multiplied. I don't have anything on the inside, so H value would be 0. I don't have anything on the outside down here, so K would also be 0. So the only thing that's happening is going to be a vertical stretch since the absolute value of 2 is greater than 1. So I'm going to say vertical stretch, and I'm going to say by a factor of +2. And that 2 is just coming from the A value. So again, my parent table, again, is just coming from these 5 points of this particular graph. So -5, -2, 0, 3, and 5. My Y value is 2, 2, -3, 1, -2. So when we apply our transformations, again, the x's aren't going to change. There's no h value here. So -5, -2, 0, 3, and 5. Here, the y values are going to change because we have an a value of 2. So I'll be multiplying each one of those by 2 and then either adding or subtracting 0 again, since the k value is just 0 here. So we're really just multiplying everything by 2. So 2 times 2 gives us 4. Again, 2 times 2 gives us 4. -3 times 2 gives us -6. 1 times 2 gives us 2. And then -2 times 2 should give us a -4. So here's our table of values that we want to go ahead and graph these points. So -5, 4, -2, 4, 0, -6 is way down here. 3, 2 is right there. And then 5, -4 is down here. And again, I'm going to connect these dots from left to right. And you'll notice that your graph, again, looks pretty much the same shape. The only thing that's different is that it's definitely a lot stretched out. It's a lot taller. So again, that happens because of that vertical stretch. And our last example has two transformations. So we've got an a value here, that 1/2 is out front being multiplied. We do have an h value on the inside here. So our h value here is -1, because again, that would be x minus -1. And our k value here would be 0 because there's nothing tagging along at the end out on the outside there. So here we are going to have a vertical shrink. And I'm going to say by a factor of 1/2. And we have movement to the left. So shifts left 1 unit. So again, my parent table is going to come from these 5 points. It hasn't changed. So -5, -2, 0, 3, and 5, and then 2, 2, -3, 1, -2. And then we're going to be applying a couple transformations here. So here we finally have an h value. So I'll go ahead and subtract 1 from each of my parent x values. So -5 minus 1 is -6. -2 minus 1 is -3. 0 minus 1 is -1. 3 minus 1, 2. 5 minus 1, 4. And then we're going to go ahead and apply our a value and our k value. So a will be multiplied, so 1/2 times y. And again, since k is just 0, we'll either be adding or subtracting 0. So the only thing that's really happening here is we're multiplying everything in the y column by 1/2. So 1/2 times 2 gives me 1. Again, 1/2 times 2 gives me 1. 1/2 times -3 gives me -3/2 or -1.5. 1 times 1/2 gives me 1/2 or 0.5, however you want to write that. And then 1/2 times -2 gives me a -1. So I'm going to go ahead and graph these points. So -6, +1, -3, +1, -1, -1.5, 2, 1/2, and then 4, -1. And again, I'm going to connect these going from the left to the right. All right, so you'll again notice that this looks pretty much like the same shape. It is a little bit flatter or a little bit wider. And again, that does happen because of the a value being 1/2. And we have shifted all of our points down 1 unit, having to do with the h value. So it is your turn to try some homework problems. Definitely let me know if you have any questions on this.